Stage is yours.
Thank you, Peter. Hello, everyone. I'm Pratibha. Are you guys a bit tired now? By now, I should say. Please raise your hand. It will give me some confidence if you're tired. Perfect. You are tired a bit. I'm nervous a bit. We are going to sail through it. So, I'm Pratibha. I've been in IT for almost 10 years, mostly working as a software engineer. Today, we are going to talk about Itertool modules in Python that provides a number of solutions, especially while working with iterators. I promise this talk is a lightweight, just to keep your evening as light as possible, and mine too. So let's begin. I'm still new to this, so please bear with me. OK, so here is the outline of the talk. We are going to skim through the introduction of Itertools, because it's only methods, methods, and methods. Then we are going to look into 3 types of Itertool functions that are provided by Itertools. It basically covers the infinite iterators, terminating iterators, and combinatoric iterators, which is quite mouthful. So finally, we will look into 3 basic interview problems as a case study, and we will try to solve them with Itertools. So let's begin. Now, what is Itertools? It provides, like I said, various functions that works on top of basic iterators to produce complex iterators. Good thing is it's a built-in module, so we are not going to do a lot of coding. And it is good for us also, because during interviews, it shows that we have some grasp of not only the algorithm, but also the library and the language that we are trying to use. It implements an iterating building blocks, and it is inspired by the constructs from APL, Haskell, and SML. Each has been recast in a form that is suitable for Python. Also, it standardizes fast and memory-efficient tools that are very good and useful by themselves and in combination. Sometimes, or as per the Python documentation, they form an iterator algebra and make it possible to construct specialized tools purely in Python. So loosely speaking, this means the function in Itertools operate on iterators to produce more complex iterators. So let's begin. Now we are going to look into 3 types of iterators and what functions or methods that justifies that it belongs to this category. The first one is the infinite iterators. Now, because of these iterators, it is not compulsory that your iterator object has to exhaust. Sometimes it can be infinite, and hence the term infinite iterators. With these, you can easily generate iterators over a sequence, and it will not exhaust for a very long time unless you mention it. So let's see the example. Count. It returns evenly spaced values starting with number mentioned in start, and step, as it's self-explanatory, tells how many steps it has to jump for the next star. It is often used as an argument for map to generate consecutive data points. Also, it is used with zip to add subsequent numbers. So it is very useful. It's a very basic method, but it is very useful when you are using map and zip, and you don't have to use a pre-generated range here. Then you have cycles. It makes an iterator returning elements from the iterable. So suppose you give a string, it will split that string character by character and keep keep it in loop, keep returning the same characters of the string one by one. Once it is exhausted, it will start from the 0. That's how it will proceed. Repeat. Now it returns object over and over again, as many times as you want. This one helps you not only in generating the infinite iterator for you to return the same response whenever somebody queries a function. It also helps you when you are mocking something or writing the test which needs some kind of mocking for a function to return a particular instances. So the next one is terminating iterators. These are used to work on short input sequences and produce the output based on the method that is mentioned. So you have an iterable, then you have a method that you have to use, and it generates short input sequences based on that. For example, these, you have accumulator. In that, you provide an iterator, and then you can provide a function that is mentioned by func. It is optional, but if it is not there, it will by default consider addition as the function. But if you mention anything, it will use that function here. So it can be a multiplication, it could be a division, it could be anything that can create a progression over here. So it returns iterator with accumulated sum or accumulated result of any other binary function that you mention. Chains. It returns an iterator with elements from the first iterable until it is exhausted. And then it will continue with the second one. Here you have to give multiple inputs, which are strings. And then based on that, it will start generating iterators for each of them. Chain from iterable is a bit different from it because your input is just a list of string. So you don't have to keep a tab of how many strings or how many parameters you have passed to chain already. You can just pass a list and it will generate the string based on that. There are few questions of programming or coding. If you go on lead code, you will notice that it is based on flattening a list and just creating the output string of each item in the sublist inside list of lists. So the functions like this can help you over there. Then compress. It filters the elements from data, returning only those that have corresponding element selectors that evaluate to true. So first, you have data, then you have selectors, and it will map the selectors for which is set to true, only those elements will be returned. Then you have drop while, which is helpful when you have to drop elements from any iterator as long as the predictor is true. So in this example, we will see that we are filtering out all the values which are less than 5, and as soon as you hit a value greater than 5, it will return the subsequent list. Filter false. These are useful when you have to filter elements and return only those where the predicate is false. And if the predicate is not mentioned, if it is absent, then it will return the items that are false. So it is helpful when you have a predetermined predicate string or list or not. So that's why it is helpful. Now group by, as the name suggests, it has group by the values of key. It returns consecutive key and groups from the iterables. And then you have islice, which is same as slicing, but it doesn't support any negative value for any of the input. Then you have pairwise, which is like return successive overlapping pairs. Then you have star maps, which are Again, you give input function name and the tuple in a list, and it will return the mapping. Again, just to give you an idea, you have take while that will return elements as long as predicate is true. T, it will generate the n independent iterators from single iterables. We are going to use this later. And you have zip longest. It is going to aggregate the elements for each of the iterables. If something is missing, then it will use fill value to put the replacement. Combinatoric iterators are recursive generators that are used to simplify combinatory constructs like permutation, combination, and Cartesian products. For example, product, it will give you equivalent to nested for loop of the product of the iterables inside it. Or permutation, as the name speaks for itself, generate all possible R-length permutation of elements. Or combination, it will generate combination without replacement for the given length R. And combination with replacement if you have repeated elements, if you want to allow the repeated elements. Phew. So much for keeping it light. So let's look into the case study. I think this is what I wanted to get it. I wanted to give you an idea of what the functions are. I won't be able to use all of them due to time constraint, but I recommend reading them in the links that I have provided in credits. So let's start. Let's build a poker app. How many of you play poker? Perfect. I don't play poker. Please don't judge me on my rules. Okay, so what you need a deck of cards. You will start with defining a list of ranks and your list of suits. Then you could represent a card as tuple, where first element is rank, another element is suit. And deck of cards will be collection of such tuples. Now, deck should act like a real thing, so it makes sense to define a generator that yield cards one at a time and become exhausted once all the cards are done. One way to achieve this is write a generator with a nested for loop over ranks and suit. However, we just saw that we have an Itertool function called products, which provide Cartesian product, which is almost the same. So let's rewrite it. We're going to use product, and the whole function will be replaced by a single line, and your deck of cards is ready. It is all fine and good, but any poker card should start with a shuffle deck. So let's shuffle our deck. As a courtesy to your user, you would like to give them the opportunity to cut the deck. If you imagine the card, being stacked neatly on the table, then you are going to allow user to pick a number, let's say n, and then you are going to split your deck into upper portion that will contain n elements and the below one, and you're going to swap and combine. That's how you cut. So we can use standard slicing for this. To generate your slice behave as expected, you have to check whether the input number that is given by user is positive or not, just to make sure that nothing crazy is happening. So cutting the deck is pretty straightforward, as we discussed. You're going to split it into n by n and n to the end, and then we are going to swap the positions and merge them. But we want to avoid creating copy of whole deck like this. So let's rewrite the cut function to cut the deck without making a full copy of it. First, we need a T to generate independent iterators from the deck. Then we are going to slice it to generate top and bottom section of it. And then we are going to use chain to combine bottom and top so that it will create a cut. Now, just a side note, it may look like overuse of Itertools, but the simplicity of logic here helps me in sending my point forward that how you can use these functions to remove the boilerplate code that you do. All right? So now that you have shuffled the card, it's time to deal some hands. You're going to deal them. You're going to write a function deal that will take deck, number of hands, hand size, and return a tuple. And now, how will you do it is, you will start by creating a list of hand size preference. Then you iterate over this list, remove the number of hands card at each step, and storing them in tuple. Then you zip these tuples to emulate dealing one card at a time. So now let's see how the game will look like. You're going to shuffle the cards. You're going to cut it into half, because 26 is half of 52. Then you're going to deal for 3 hands here. Now, if you look at here, all the 3 players have received 5 cards of different combination of rank and suite. In starting, you had 52 cards. What do you think the state of card is now that you have dealt 3 hands of 5 cards? 37, because you have dealt 3 into 5 times cards already out of it. The 15 cards are dealt, which is exactly what you want. And as the game continues, the state of card iterator reflects the state of deck and play. Let's look into the next one. How many have you seen this problem before? Really? Good. So this is the problem which usually people use backtracking or dynamic programming to figure out how to do it. Brute force is you try to list out the ways to choose one bill from the wallet and see if it makes 100. Then you try to find the 2 ways to pick 2 bills and see if it makes 100, so on and so forth. But we love Python, so we like to automate it, because that's what we use our Python for most, to automate and make us more lazy. Make me more lazy, because that's what I use it. So let's first create a list of bills that we have. Now, we know that a combination is called a choice of k things from a set of n things. And we know that Itertools have a combination in place, so let's use that. That's what I'm saying. Perfect, thank you. I think so. Yes, thank you. Okay, so to list the combination of 3 bills, just use the combination function. Now, to solve this problem, we are going to first create a list of 3 bills each. And then we are using this to make sure that we use 3 bills only to solve our problem. So that's what we are going to use it here. And now we are going to loop over positive integers from 1 to length of bills and see how we are going to create a combination so that its sum is 100. Now, if you look at this code snippet, it will create all the combination that will have the sum, all the combination that will have the sum 100. But it will have some duplicates also, because our input have duplicates. Now, this is, to make it unique, we are going to use set. And by using set, we figured out there are only 5 ways for this problem. If you do it traditionally, the code length is quite long. But if you use it like this, it will show that you not only understand the problem, not only understand the algorithm, but you also understand the programming language that you want to use. Now, I'm going to show you one quick part, a small variant of this. In this case, you don't have a preset of bills. So you need a way to generate all possible combination using any number of bills. For this, what we are going to use, previously we used combinations because we know how many bills we had. But this time we don't know, so we are going to use combination with replacement because it allows elements to be repeated in the tuple it returns. So let's start with all the denominations we have. We have 50, 20, 10, and 5. And here is how the revised solution will look like. In this case, you don't need to remove any duplicates because it will not produce any duplicates. Each value, each item in the iterator will be identified uniquely for its position, not the value. That's why it will not create any duplicate. If you run the above solution, you notice that it will take a while to output the display because it processed 96,000 million combination. And the phenomena of just few inputs producing large result is called combinatory explosion. So we have to use these things thoughtfully in terms of CPU and memory. Now, because we have unlimited number of denomination nodes, the result will have more items in it, more solutions in it. With this, my talk has come to an end. And here are the credits where it is due. They are really helpful. Google search, I love you for helping me always. And Itertool is really powerful in Python, not only in terms of coding, but in other day-to-day life as well, especially when you're parsing the large data set. And the solution that it provides is fast and more memory efficient. So hence, I always rely on it whenever it suits the need. In the end, Itertool is a testament of power of iterator and lazy evaluation. I hope you enjoyed the talk. Thank you.
Thank you very much, Pratibha. We do have a few questions for you. Is there a difference between the take while and the filter function?
Good question, because I also have to have a quick look. You mean take while?
Take while and filter.
Filter function. So filter function will return only those for which predicate is false. And while take while will return as long as the predicate is true. So as soon as you hit a false, take while will stop. Whereas filter false will keep checking, and for whichever the predicate is false, it will return that.
Thank you. Do we have any questions in the audience? Not yet. Could you please recommend a tutorial on Itertools?
It really helps to understand what you want to do with it. If you just want to read through it, in the credits, I've given the link of the actual documentation of Python. It's very elaborative, very self-expressive. So it always tells you where you can fit this code and make and use it as a boilerplate rather than writing your own code. But if you are looking into how to explore it large data sets, then yes, there are many tutorials online which you can explore and see how you can process large data sets in a memory efficient way.
Thank you. And if Itertools aren't enough, could you recommend another library that expands the capabilities?
So like Itertool is built-in module. Similarly, you have collections module, which is very helpful. I have used it when there are questions I have to solve for strings. And I use Itertools whenever there is a probability-based questions, because it always simplifies our approach, or at least the code.
Thank you. Any more questions? There one.
Hi. Do you know whether there is any plan to integrate asynchronous Itertools into the standard library?
I don't know, to be honest. Sorry. But it would be lovely.
Any more questions? Now's a great time to ask. But if we don't have any, then let's thank Pratibha.
Thank you.